All right, and welcome back. So today we are going to be talking about how to solve what we call simple equations. So today we're going to talk about how to solve equations that involve addition and that involve subtraction. Next time we're going to learn about multiplication and division. So today we're going to be able to solve one-step equations by using addition and subtraction. So here we go. Before we move on, we need to establish some kind of vocab. So you're going to hear me say an equation. An equation is a mathematical statement that two expressions are equal. Remember, an expression does not have any equal sign, but an equation does. So for example, this is going to be an equation because we have the equal sign. Technically, x plus 6 and 9, these are expressions. Alone by themselves, they would be called expressions. But since we have the equal sign, this makes it equal. This makes it an equation. We also are going to be talking about the solution of an equation, and it's the value of the variable that makes that equation true. Technically, we can just say x can be 20, x can be 5, x can be negative 42. We can say whatever we want to say, but when we're trying to find the solution of the equation, it's going to be one value or sometimes two, but we'll talk about that way later in the year. That is going to make that solution a true statement. So for example, our solution here is 3. X is equal to 3. And that's because if we substitute 3 in for x, we're going to get a true statement. Our equation is x plus 6 is equal to 9. So if we substitute 3 for x, we get 3 plus 6 is equal to 9. Well, 9 is equal to 9, which means that that is indeed the solution of that equation. We also have some commonly used expressions, and do not get it twisted about expressions and mathematical statements and vocab expression. These are commonly used phrases. I should say that. A commonly used phrase. We want to isolate the variable. That means we're getting the variable all alone. We want to get that variable on one side of the equal sign without any other terms there. We don't want any coefficients. We don't want any terms. We just want to isolate that variable by getting it all alone. We're going to be using what are called inverse operations. So they're opposite operations that undo each other. For our examples, we're going to be talking about addition and subtraction. Those are opposite operations. And multiplication and division, those are opposite operations. And we also can refer to these as being inverse operations. And last but not least, we have to keep that equation balanced. We're going to be doing that by performing the same operation to both sides when we initiate some kind of step. And I'll talk to you about the differences between them a little bit later in the year. But what we do to one side, we have to do to the other. So let's go through an example. We're going to be solving this equation by using addition. We're going to solve and we're going to check. And the reason why it says by using addition is because if we look at this problem, we have x minus 10 is equal to negative 4. I want that x to be all by itself, but right now it's x minus 10. I want this term to be 0, but right now it's negative 10. Well, what do I need to do to negative 10 to bring it up to 0? Well, I have to add 10. So that's why we're calling by using addition. We're going to add 10 to both sides to keep things balanced. Negative 10 plus 10 cancels out, and it's equal to 0. Therefore, we're just left with our x on one side and our integer operations, negative 4 plus 10. If you think of it as money, your bank balance has a negative $4 balance. You deposit $10 in there. You don't have $10 because you've got to pay back the bank $4. And what you have now is $6 remaining. So our answer is going to be x is equal to 6. When we want to check it, we always start out with the word check, and we make it clear that we are checking our work. We're going to go back to the original equation, x minus 10 is equal to negative 4. We're going to substitute the value that we have for x into the equation. So our value of x is 6. So it's now going to be 6 minus 10 is equal to negative 4. We're now going to simplify both sides of the equation separately. We have 6 minus 10 on the left-hand side. Well, 6 minus 10 is negative 4. I can't simplify anything on the right-hand side, so I end up with the statement of negative 4 is equal to negative 4. Since this is true, we know our answer of 6 is correct. If it was a false statement, let's say we had negative 10 is equal to negative 4. That's not a true statement. So that means the answer that we had was wrong. All right, folks, great job so far. Let's keep this train rolling. Let's try out this problem. We have x plus 6 is equal to negative 6. So it says we're going to be using subtraction here. And you might be able to put 2 and 2 together here as to why we're using subtraction. We have x plus 6 is equal to negative 6. Again, I want the other term that's with the variable to end up being 0 because I want that x all by itself. Well, I have positive 6. How do I change positive 6 into being 0? I have to subtract 6 on both sides. 6 minus 6 goes to 0. I'm left with x is equal to negative 6 minus 6. So we're starting at negative 6 and we're going 6 more to the left or 6 more in the negative, which ends up with negative 12. Let me change that color real quick. So we end up with x is equal to negative 12. But first we need to check our answer before we are done. So we're going to write check. We're going to go back to the OG problem. X plus 6 is equal to negative 6. We're going to substitute in that x value that we had, which was negative 12, for our x. Or a variable, I should say, because we don't always use x. And now we're going to simplify. Negative 12 plus 6 ends up with negative 6. The right-hand side is already simplified, so we end up with negative 6 is equal to 6. This is true, which means that this answer of negative 12 is correct. Awesome, folks. Let's keep it going. What about this problem here? It looks a little bit different. Because our variable is on the right-hand side of the equation this time, but that's okay. We're still going to use the same properties here. We have m plus 0.4 on the right-hand side and negative 0.7 on the left-hand side. Again, we want this term to end up being 0 because we want that m isolated. We want that variable to be all by itself. In order for us to do that, it's currently positive 0.4. We have to subtract 0.4, hence why it says using subtraction. We're going to subtract 0.4 on both sides. Cancels out over there. Negative 0.7 minus 0.4 give us negative 1.1 is equal to m. And now let's check our answer to make sure that our answer is correct. So we go back to the OG. Don't forget your negative. We're going to substitute in the value that we received for our m, which is negative 1.1, and everything else is going to drop down. We're now going to simplify. We get negative 0.7 is equal to negative 0.7, and this is true, which means that our answer of negative 1.1 m, or negative 1.1 is equal to m, is going to be correct. And last but not least, let's go with one other situation here. Normally, we see that our variable is all by itself, or it's the first term within an equation. But right now, we have negative 8 plus y is equal to 2. We're still going to be using the same general idea that we want that variable all by itself. We currently have a negative 8. We want this to be equal to 0. So in order for that to happen, we have to add 8 to both sides. That's why we're adding the opposite. When we do that, that cancels out. We're left with y is equal to 2 plus 8, which is 10. And we're going to check our work. And we're going to check our work here. We have negative 8 plus y is equal to 2. Do you notice what I did not do? I did not follow the rules that we have. I didn't write check. Now we're going to substitute in our value of y, which is 10. That should have changed color. Let me go back and do that for y'all. And now we're going to simplify. Negative 8 plus 10 gives me 2. The right is already simplified, and 2 is equal to 2. Alrighty, folks. You've done a great job with this so far. You've done a great job with this. Please answer the following question that I'm going to be posting within the video, and you have a great day.